Okay, so there seems to be a little bit of anxiety going around about the homework problems. So I thought that I would give some suggestions for the homework problems. I'm not going to start with problem 1 since I've managed to thoroughly confuse enough people about problem 1 already. I think I'll start with problem 2 and work my way sequentially through. Although, I should point out that the order that I would probably do them in is not the order that they're written in if I were sitting down to do the homework. So I probably, for instance, would think problem 3 would be the easiest one to start with. But anyway, let's look at problem 2. So problem 2 says another way to generate a topology on a set X is from a subbasis, which is a set S of subsets. Maybe I should be underlining this. So a subbasis is what? It's a set of subsets of X, such that for any X in X, there is an element of S. In other words, there's a set in this set of sets, such that X is in S. What's that saying? Well, that says everything in X is in at least one of the sets that comprise your subbasis. So then the question is two-part. First part of this question is, show that the collections B sub S, which is defined as all intersections, all finite intersections actually, of elements of your subbasis form a basis. So let's stop there and see if we can think about that. So we want to show that if we have a subbasis and we take finite intersections of all the elements of our subbasis, we get a basis. So to prove that, it requires us to remember what a basis is. So a basis is a collection of subsets of X, right? Subsets of X that satisfies two properties. One is one of the same properties that a subbasis has to satisfy, and that is everything in X is in at least one of the elements of the basis. And the other thing is that if you take two elements of your basis and you intersect them, there's a set in your basis that lies in that intersection. Now it actually could be the whole intersection. So notice that if you assume, let's say script S is a subbasis. Show script B sub S, which is all these intersections, in other words, finite intersections from the subbasis, forms a basis. So we have to confirm two things. We need to show that for all X in X, X is in some element of X lies in some finite intersection of subbasis elements. And so X is in one of the S's or in some intersection of the S's. Element. But that's actually given. X is an element of B sub n. Sorry, B sub n for some n. But that's by assumption. Because the subbasis already has that property. So intersections of sets of the subbasis are certainly going to have that property. And what else is it asking for? Well, the other thing it has to have is if we intersect two elements of our B sub s, do we get something in the intersection? And so 1 is already checked, and property 2 is trivial since you can notice that all intersections are in script B sub s. So that's not a formal proof, that's just pointing you towards the right answer. But the answer lies in this definition up here, how you're defining the sets in B sub s. So that should at least get you started on problem 2. Problem 3 asks you to show that a certain definition of open sets is a topology. And if you look down the page, you'll find an example of what's called the finite complement topology. So that's what that FC is supposed to stand for. And this looks what? It looks suspiciously like the definition for the Fort topology, except for the possibility of open sets in which X naught is not in U. And this is a proof that you can emulate. In fact, this does 90% of the heavy lifting for doing the proof for problem 3. The difference comes in that you have to take into account the fact that there are more kinds of sets here. In other words, you have to take into account that, so step 1 is actually exactly the same. Step 2 uses De Morgan's laws again when the sets are of the form X minus U is finite. Then you have to figure out what you can say about those sets that exclude X naught. And again, for part 3, this looks very much like the proof you need to do for part 3. So this would be a good one to emulate and just augment a little bit, and it's in your book.